Hello friends, let's see what this question has in store for us. As always, feel free to pause the video at any time and begin to think about what the question is asking, what the next page is about, anything like that. Do some of your own thinking, because if you're doing your own thinking, then you're not using my brain, but you're using your brain, which will help you find more success. So let's look at this question. The function f is defined by that power series for all real numbers where we have a convergence. G is defined by that power series. Okay, so we have two different power series, and they don't look exactly like anything that we know, although that bottom one looks a little bit like cosine, but without a 2n. And yeah, okay, so we could figure out kind of interval of convergence type of things by using the ratio test. And because neither of these is geometric. If they were geometric, we could do some other interesting stuff. And we could kind of compare them. We might have to integrate them at some point or find derivatives of them at some point. We might have to combine them by some sort of addition or subtraction. There's all sorts of things we could do. But for right now, it's pretty nebulous about what we're supposed to do. So let's get going. And let's see what we have. We still have those two series that were given. Find the interval of convergence for the power series of f. So that suggests we should do the ratio test, as I mentioned on the front page. So let's set up the ratio test. We need to put the limit as n goes to infinity. And remember, the ratio test is the next term over the general term, I guess, if you want to say it that way. So I'll write this out. We have the general term of f, but we have to make it n plus 1. n plus 1, n plus 1, x to the n plus 1 over n plus 1 plus 1. That's just the n plus 1 term. The nth term, then, is negative 1 to the n, nx to the n, over n plus 1. Ooh, that's a lot. Now let's see. We can simplify this. We have the limit as n goes to infinity. The negative 1 to the n's don't matter because of the absolute value. And let's see. This will stay on the top. So I'll have n plus 1 x to the, that's not an x, to the n plus 1. And I'm going to multiply by n plus 1 here. I should put parentheses there. And n plus 1 here. So that's going to give me another n plus 1. I'll write that down here. Then on the bottom, we have the n plus 1 plus 1. I'll call that n plus 2. And then I could kind of divide, and this is going to move up there. So negative 1 to the n goes away. We'll still have an n. I'll put that over here. And then an x to the n. Whew, a lot of stuff going on here. Now, let's consider these pieces. This piece, as n goes to infinity, those are going to be basically the same. If I take a huge number and add 1, and then take that huge number and add 2 and divide, I'm basically going to get 1. Same argument here. If I take a huge number and add 1 and divide that by that huge number, like 10 billion and plus 1, and then divided by 10 billion, that's basically 1. So both of these go to 1. And then we have x to the n plus 1. Maybe I'll show this step just in case we need it. I'll have the limit as n goes to infinity, x to the n plus 1 over x to the n. Still have my absolute values. Well, n plus 1 and n, if we use our Algebra 1 skills, that will simplify to simply x. You subtract the exponents. If you think of quantities, you have n plus 1 x's on the top and then n x's on the bottom. You can cross out n x's and you're left with 1 extra. Now, the ratio test is connected to the geometric series test. We want this to be less than 1. So we know that our interior interval of convergence is negative 1 to 1. Now our job is to figure out, do I include the negative 1 and 1 or do I not? So let's think back to that general term. The general term was negative 1 to the n. n x to the n over n plus 1. So that was our general term. General. Now, let's think about if x equals negative 1. We'll have negative 1 to the n, negative 1 to the n plus 1. And actually, I'm going to get rid of this arrow, make it smaller, because I have an idea. The limit as n goes to infinity. If I consider these two, plug in any n value you want. Let's plug in 22. Negative 1 to the 22nd is 1. Negative 1 to the 22nd is 1. And then 1 times 1 is 1. So these cancel each other out. These aren't going to matter, because if I picked 7, which is an odd number, I'd have negative 1 here and negative 1 here, so it'd be positive 1. So really I'm just worrying about n over n plus 1. Well, as n goes to infinity, that goes to 1. If I get 1, that's the divergence test, and that means that that series will diverge, because we looked at the sequence. That's this blue part. We looked at the sequence. The sequence did not go to 0. If the sequence does not go to 0, then the series must diverge. And if x equals 1, but we're going to have a similar situation, so I'll set it up the same. Negative 1 to the n, and then x is now 1. 1 to the n does nothing for me. And let's see. So 1 to the n does nothing for me. This is going to be the same idea as before, where n over n plus 1 is going to get me 1. And then the negative 1 to n is either going to be 1 or negative 1. So I'm going to say equals does not exist, I guess. It's 1 or negative 1. So we don't include that either. So we got from negative 1 to 1. Not including the endpoints. The graph of f minus g passes through the point 0, 1. Okay, so that's going to be important. Find y prime and y double prime at 0. Determine whether it has a relative max, min, or neither at x equals 0. Give a reason. Okay, so we need to consider f minus g. Well, let's write down f. X over 2, 2x squared over 3, 3x cubed over 4, negative 1. That's not a negative 1. Negative 1 to the n, x to the n over n plus 1. And let's consider g. We're subtracting. So minus 1 plus x over 2 factorial minus x squared over 4 factorial plus x cubed over 6 factorial plus, and the general term, and I'm doing more work than I need to, I guess, because I only care about the first part of it. So this series, if I subtract, is going to be, so we have f minus g. F minus g. Negative 1. These are going to cancel. So I'm going to say plus 0x. And then that's going to be plus 2/3 minus 1 over 4 factorial x squared. And I'll say one more, but I'm not going to need it. So plus negative 3/4 plus 1 over 6 factorial x cubed, and so on. Now, let's think of a Taylor/Maclaurin series in general. In general, the series is going to be f of 0 plus f prime of 0. That was not a 0, that was an x. Times x plus f double prime of 0 times x squared over 2 factorial, and so on. And I'm being asked to find y prime of 0 and y double prime of 0. So, if I consider this y prime of 0 equals 0. And y double prime of 0 over 2 factorial equals this piece, 2/3 minus 1 over 4 factorial, because the coefficients have to match up. So that means y double prime of 0 equals 2/3 minus 1 over 4 factorial times 2 factorial. I could figure out what that number is, but I don't really care. So I found the two numbers. Now let's see. They wanted me to consider whether we had a relative min, max, or neither. Well, since y prime of 0 is 0, and y double prime of 0 is greater than 0, f minus g, is y equals f minus g? Let me double check that. Y equals f minus g? Yes. Y equals f minus g has a, okay, let's process. Right here, this is saying y double prime is greater than 0, which means the function is concave up. So the function y is concave up. And if the derivative is 0 and the function y is concave up, then we have a minimum. Has a minimum at x equals 0. All right, the whole question, whole shebang. We were given two series. We didn't know what they were. They were not specifically named, like sine, cosine, or e to the x, or anything like that. We had to find the interval of convergence. To find the interval of convergence, we use the ratio test. Don't forget that limit and the absolute value within the ratio test. And then we had to consider the endpoints. So we got -1 to 1, and we had to consider both endpoints of -1 and 1, and use different tests, in this case the divergence test, to see if those endpoints worked. In part B, we had to combine the series. That seemed a little scary, but if we just did piece by piece, we combined like terms, we really only cared about the first three terms. The constant term, which we knew was -1, because it says so right there, and then y prime of 0 and y double prime of 0. So the constant term, the linear term, and then the quadratic term. And then to determine whether we had a minimum, maximum, or neither, I considered what the value of y prime was, which was 0, and what the value of y double prime was, which was positive. And that means the original function y was concave up, so we have a minimum. As I think about it, I don't know that I ever said that we did not include -1 and 1 because of the divergence test. So if I had to go back, I would change that, because I bet that that's an important piece. And let's look at the rubric. So they set up the ratio. They did not talk about limits at first. They just set up the ratio, simplified that ratio, and then figured out that the limit of the ratio using absolute value stuff was the absolute value of x. So they said -1 to 1. And then they checked the endpoints. This series does not converge. That's the divergence test. You could use that argument also. I guess my justification is in the limit. So I did argue that without saying the divergence test. And then at -1, same idea. Limit of individual terms is not 0. Thus, the interval of convergence is -1 to 1. So we did that. Beautiful. And for part B, they wrote the derivatives, interesting, and then they found the value, and then how did they get to the 4/3? Oh, they just copied it. So right here and right here. That's fine. Same idea as what I did. A little different, but same idea. I just combined the functions. I didn't take the derivatives of the individual series, but that's a totally valid thing, obviously, because they did it. And so they figured out y prime. I guess you could have continued their reasoning. They didn't show it, but you could have written f double prime is -4/3 minus 18/4. I know I could reduce that. X plus, not x squared, just x plus, and so on. So then f double prime of 0 is no, that's a positive, thank you, positive 4/3. So you could argue it that way too. Sure, makes sense. I combined and then considered values. They just took some derivatives and looked at what those values were. Either way is beautiful.